No. So since there's no homework assignment, we had a bell work instead. Doesn't mean we'll always have it that way, but sometimes. So distance between, distance, as soon as you saw that word, what did hopefully a lot of you guys think of? The distance formula. Good. From section, wasn't that 1.1? Okay, so distance formula from section 1.1. And how does the distance formula go? Equals. Okay, so how did you guys go ahead and plug into that formula then? Who'd you make your x2? You could have made it 1. I wouldn't say it's a bad thing. You could have made it 1, and so it would be 1 minus x quantity squared plus 3 minus y quantity squared. But just because I know what I'm going for, I'm going to actually do it the other way. Is that okay? So that one's my x1, y1, that one's my x2, y2. So wouldn't it be just as accurate to make this guy the first one? Minus, and then what's the other x? And then what would the other expression be? Good. Y minus 3 quantity squared. Then I was like, in your groups, look at that thing, look at that equation, see if it looks like anything else you've ever seen before besides the distance formula. Distance between any arbitrary point and the point 1, 3. And then I said, play around with what if the d was what? What did I say? 3. And I gave the hint, maybe use your graphing calculator to try to figure out what function this is. What's so special about this idea? The distance between any arbitrary point and the point 1, 3, and then all of a sudden I was like, what happens if the distance is 3? What results? When you guys, or if you guys went to your graphing calculator, how do we think about graphs in the graphing calculator? Where do we go? Good. But how do you do y equals if it's 3 equals? Did you catch my other hint? What, Robert? Yeah, the f of x thing, but f of x is just a snazzy name of saying who? Y. I need to get y by itself. Otherwise, I can't plug it into my graphing calculator. Kyle? Exactly. So let's rearrange this a little bit to try to get it in our graphing calculator. When we rearrange it, square both sides. That's a great idea. So I would have 9 equals. What happens when you square a square root? Disappears. Or I should say, simplifies away. Then I have my y minus 3 quantity squared. What do I have to do next to get y by itself? Subtract the whole sum, right? So 9, or the whole term, 9 minus x minus 1 quantity squared equals, if I subtract that away, I still have y minus 3. Ugh. I can square root both sides. Technically plus or minus. If I square root a squared. Has to do with absolute value. We'll talk about it at some point this year. Plus or minus square root would simplify away the squared. Last step. Okay, so I can say y is equal to adding the 3 plus or minus the square root of 9 minus x minus 1 squared. Whew. All right. Sadly, no. But, yeah, why is Kyle saying, I can't do plus or minus, I have to do it twice then? One's going to be an addition. One's going to be a subtraction. So we're going to go ahead and throw in the 3 plus the square root of 9 minus x minus 1 quantity squared. Looks good. Then I can do 3 minus the square root. 9 minus the quantity x minus 1 quantity squared. That would be a struggle. Thank you, Robert. Put a little too much. Ooh, does anybody, do you remember the shortcut I told you how to get to the end of the line real quick without having to scroll? Second over. Or you can do second back. It jumps to the end, jumps to the beginning. It's helpful for me because my program is kind of slow and laggy, yeah. So I can just delete that real fast. Delete is how to get rid of one character. Clear is how to clear the whole line. What do you guys notice about the graph? Yeah, I could zoom out, I could zoom standard. Which one looks better to you guys? Zoom standard, because you can see it? Okay. Why does it make sense it's a circle with a, well now, first of all, my calculator broken or is my circle broken? Neither. Your calculator, did any of you guys that have the newer calculators, did it get a little bit closer together than mine? Oh, no? Oh, looks a little closer together to me. Okay. Long story short, do you guys know why the circle looks all jaggedy? Is it because circles are actually jaggedy and not round and smooth? We've been told lies all this time. No. Why is it jaggedy? What's it called? Pixels. Yeah, it's all about the pixels. It's not like your new smartphones and how many pixels, however many, whatever. Calculator screen does not have near as many pixels. So the struggle is it's pixelated. And maybe if you guys have ever seen old pictures or pictures that were taken low quality and zoomed in, you're like, right? That's what's going on here. So a circle eventually goes straight up and down, but the problem is in this mode, function mode, nothing goes straight up and down because that would be failing the vertical line test. Another way of thinking about it is the circle was meant to be getting, or continually going over more, over more, over more, over more as it goes around. But at some point the pixels are like, I can't go over anymore. It's illegal because it jumps me past the circle. So it just kind of cuts off and says, I can't do anything else. And you're like, great. Your brain has to attach it and say, oh, it's a circle. Calculator failed with the pixels. Okay? But anyway, hold on, pause. It's a circle. What do you think the center of the circle is? 1, 3. The center is 1, 3. So what does this basically give you an equation for? What does a compass do? Okay, sorry. What's a mathematical compass do? Remember the little pointy thing and you kept on stabbing your finger when you were little and then there was the pencil and the other one that kept on falling out, right? And it was just brutal. It makes a circle, right? How do you know how big the circle is? The distance between the two is the radius, right? The distance from wherever you stick the little pointer is the center, right? Wherever you stick the pointer, then you can figure out the distance. Mathematically, this does the same thing. Whatever distance you want for the circle, with whatever center you want, whatever point you're measuring from, this equation will give you the circle for any center, any distance away. So I said 3, so guess what the radius is of the circle that we're looking at right here? What do you guys think the radius is? Yeah, because the distance is 3. What if I was to say the distance was 5? How big would the circle be? What if the distance was 10? What if the distance was 20? So whenever you establish the distance, you've made your circle equation, and maybe a few of you guys recognize this from last year. X minus h squared plus y minus k squared equals r squared. Maybe you didn't need to do all that work to say, oh, it's just a circle. Why? Because in geometry, we learned that a circle is really just the collection of all the points a certain distance away from a set point. Dun, dun, dun. Okay, so that was fun. That's using the distance formula. Let's go ahead and get back to section 1.2. So, homework spiral is closed. That was a fun little exploration. Section 1.2. That was just using the distance formula because you guys saw it in 1.1. I don't know. I thought of that one a couple days ago, and I was like, that'd be a good bell work. Anyway, there you go. You're welcome. Tying together geometry, algebra 2, and the very beginning of pre-calculus. All right. Section 1.2 we've talked about so far. What solutions are. Did you guys do any homework about solutions last night, starting the assignment? Was it hard? Right? No, you're plugging in and true or false. True, it's a solution. False, not a solution. Going over here, sketching graphs, this was just reminding you tables are okay. Even though you're in pre-calculus, tables are okay sometimes. But then, oh, hold on. This, can I go around it? Huh. Yeah, I can. Good call. So I can go back there and forward. Oh, I can do both. Okay, tables are valid, except we don't want to just be stuck with tables because we're supposed to have grown since Algebra 1, theoretically, right? Physically, academically, mentally, spiritually, hopefully all the above. But even though tables are still valid, we do have clues. And so the clues we talked about yesterday, reviewing really quickly the x and y intercepts, just follow the procedure and you should be good. But my quick reminder was if you have any sort of polynomial, to find the zeros, snazzy name for the x-intercepts, even though there are y-intercepts also. But if you're finding the zeros or the x-intercepts, always, 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 always look to factor. Don't forget that part when solving. But moving on, symmetry. All right, here's where we left off yesterday. And some of you guys, there was at least one or two in here yesterday that were working on this and got to go further in their homework because they looked at some examples in this section. That's excellent work, especially for honors pre-cal kids. So even though you might not have gotten stuck here in homework, let's pause here for just a second. Symmetry. Okay, so I showed you guys these graphs yesterday about symmetry. What's it doing? Still on my yellow marker. Let me get it off that. Okay. Still. Huh. Never had that happen before. Do it the old-fashioned way. All right. X-axis symmetry folds across or has symmetry about the x-axis. Y-axis symmetry, symmetry about the y-axis. If you were to fold origin symmetry, you have to have both x and y in a sense put together. It flips across and down for origin symmetry. But what we saw at the very end of yesterday, I was trying to give you like a little clue or clues or steps as far as how to test for symmetry. If it does have x-axis symmetry, you should be able to plug in what I called the corresponding point. X-axis symmetry, xy should correspond to x negative y. So we would plug that into a function and simplify it. If it ends up the same, that's the key phrase, the same. If after simplifying you get the same result as the beginning, they both work, they both match up, they both give true statements, and therefore the symmetry exists. So what we're going to do is plug in or test each corresponding point with the symmetries, and if after simplifying this still gets a true statement based on the original equation, we can say yes, the symmetry exists. If it gets a false statement as compared to the original function, then we would have to say the symmetry does not exist. So let's get to an example, and I think I have one. Nice, right here. So using that page I just said, we're going to test for all three symmetries. So the first one, just to go in order, nice and neat, wasn't x-axis the first symmetry? Okay, we're going to test for that one first. Then y-axis symmetry. Then origin symmetry. Okay, x-axis symmetry, y-axis symmetry, origin symmetry. And before we actually test, let's just really quickly recap. What's the corresponding point for x-axis? Okay. Some of you have it memorized already. Some of you would just go back and read your notes, but let's think through it logically. Ready? X-axis symmetry. Here he is. XY would go over and up. If you have x-axis symmetry, what else can you do besides xy? X negative y. It has to flip, so x negative y. If you're visual, that might help. Y-axis symmetry. XY would map to what other point? Negative x, positive y. Now, if you're not a very visual person, that's okay. Highlight those corresponding points and maybe start studying, making some flashcards, etc. Depends on your brain as to what kind of learning you need to, or what kind of studying you need to put in. Origin symmetry. This one's a little weird. Pretend the point's over there. So, x, y in the first quadrant. Origin symmetry, where's it going to go? So how do I get opposite of x, y? Negative x? Got it. Okay, that's just how to remember if you're visual. Remember, negative x goes the opposite direction as far as left. Negative y goes the opposite direction as in down. Okay. So if I was to take this original equation, there are two spots where we can be plugging in. I put parentheses around those two variables because those variables are really just kind of holding spaces for inputs and outputs. They're just holding spaces, holding spots. So for this corresponding point to work, we need to plug in for y and for x. But the pattern remains the same as far as output equals input squared minus 4. So the output, or the y, is now a negative y. The x remains the same. And then simplify, so negative y is equal to x squared minus 4. I guess we could multiply both sides by a negative, but here's my question. Is there any way that this is going to stay the same as that? No. So is this and that the same equation? And the answer is false. If it doesn't match up, guess what symmetry it doesn't have? It doesn't have x-axis symmetry. It doesn't match up. You might be like, well, aren't they all going to be false because they're all changing something? Well, but check out this guy. Some of you are already going. That's great. Just separating so that we can keep it all nice and clear. This one we're plugging in for the y. Oh, y stays the same. X needs to become a negative x. What happens when we simplify this guy? Positive x squared, because a negative times a negative is a... So do these two match? So what kind of symmetry does it have? Y-axis symmetry. And last but not least, origin symmetry. Do the exact same. It is going to be like the first one. Because the negative x is going to become a positive x squared, but the struggle is the negative y. There's no way to magically have that disappear. We can move it to the other side, but then it messes up the other side. It's not the same. Does that kind of make sense how the tests work? You can take the corresponding points with each symmetry just based on the actual reflection or the actual symmetry itself, and then plug in and say, hey, do they both work? Does this point end up giving the exact same result as the original? If the answer is false, then it does not have that symmetry. If the answer is true, then it does have that symmetry. So what symmetry, or I should say symmetries, if any, does the following display? Only y-axis symmetry. Now, if you guys, which hopefully some of you, or most of you, or all of you, if you remember your study of quadratics last year, couldn't you maybe have just been like, hey, it's a parabola shifted down 4, y-axis symmetry? Yes, and that is a nice shortcut, and that is a nice help if you know what this guy looks like. But remember how yesterday we said that sometimes we're going to have harder functions? Should you be able to graph a line and see if it has symmetry? Yes. Should you be able to graph a he's not quite as nice. Could you have? Maybe. Would it have been easy? Maybe not. Now maybe you would have used our trick of intercepts to be like, I wonder where this guy hits. So that's going to be x and x minus 3. So I don't know much about the parabola, but I know it's up, concave up like a cup because he's positive, smiling. You can think of it that way. He has a 0 at 0. He has a 0 at 3. I know a vertex usually happens somewhere in between. No symmetry. It doesn't fold that way, doesn't fold that way, doesn't fold that way. It folds here, but that's not x or y or the origin. Okay, maybe some of you could figure out something to do with him, but he's just not as easy as the parabola we just did. And that guy, well, we'll leave him for another day. By the end of pre-cal, hopefully we'll know how to do that guy too. But not even the end of pre-cal, like by the end of second chapter. But anyway, yes, sometimes the pictures are great, but sometimes it's much nicer to be able to have like an algebraic trick to do the equation and not have to worry about pictures. Let's zoom in here to the bottom. I copy and pasted, literally, kind of. Actually, I snipped, if I remember right. The snipping tool is my best friend. From your textbooks, this is exactly what it shows. Their way of saying the algebraic test for symmetry. But you guys check it out and see if it's basically the exact same thing we just did. You can write this down, you can memorize it, but maybe you don't need to. X-axis symmetry, what was our corresponding point? x negative y. What are they saying to do? Replace y with negative y, and it should be the same. Well, that's what we do when we we replace x with x. Okay, it stays the same. Y with negative y. So if you're plugging in the corresponding point, you're doing test 1. But some of you, it might be helpful to have some of those extra words. Y-axis symmetry. What's the corresponding point? Negative x, positive y. So aren't you ultimately replacing x with negative x? Y stays the same. So you're ultimately doing the same thing. And last but not least, origin symmetry. If we're thinking about negative x, negative y, we're going to replace x with negative x, replace y with negative y. So when you plug in the corresponding points, my trick is just not making you think through the sentences, but those are the steps that ultimately we're doing. I didn't want you guys to think that we're doing something different than the text is actually telling you. We're doing the same. So if you guys used this last night in homework to keep going, that's fine. It should have worked just the same as it did with us. Okay? We're going to talk more about symmetries because there's those words, even and odd, and function notation, but not for right now, not for today. Let's keep going. Look, it was our bell work. I'm not even sure I actually had that planned in my head, but it worked quite nicely, so that's nice. Maybe my brain just remembered that circles came up again. How many of you recognized the circle before we got the graph and the graphing calculator? Really? Oh. You didn't have to. There's no judgment in that. I was just a little surprised, but that's okay. Good thing we have it in our notes today, huh? Circles. X minus h squared plus y minus k squared equals r squared. It's one of the beauties, but also the really frustrating things about math, that you can be doing one type of problem and suddenly this concept or this thing or this algebraic step from like 3 years ago pops up and you're like, oh. And you're supposed to just remember it, and sometimes you do and sometimes you don't. So here you are solving for some weird distance bell work thing and that circle pops up. But it's not something you see every day. Well, the equation isn't something you see every day. So you're not familiar with it, so you don't recognize it. Which is why Precal has to review a lot of stuff from algebra. Because we're trying to make you masters at some of the concepts you were just introduced to in Algebra 2. So that whenever you see higher maths and some of these things come up, you're like, oh yeah, I remember that. Maybe not everything, but at least a lot of it, hopefully. So what's going on? Do you guys remember from our bell work? What was so special about the point that was put in here? It was in the middle, otherwise known as the center. Good. So the center will always be HK. So if I wanted you to have a circle, or if you wanted to have a circle somewhere else besides, what was it, 1, 3? If you wanted a circle somewhere else besides 1, 3, just change the point that you're measuring the distance from. Or with the compass, pick it up and put it somewhere else, and then measure your distance from a new point. So HK is your center. What's your R? Your radius. In R's, when I said the distance from the point was 3, that was the radius because that would measure all the way around. So what would the diameter be? What would the distance across the circle be? 6. But what ended up showing up in our actual bell work? In our circle equation, not 3. What ended up showing up was 9. Why? Because we had to square both sides from our distance formula. That's why you see the 9 there. You're going to have to square root that, or you're going to have to think of, wait, 9 is who squared? In order to get the radius from the equation, or the standard form of the equation of a circle. Here's the weird thing. That is one version, or that is one form of a circle. What's another form of a circle? This one. With an actual distance plugged in. This is just a general circle right now. Any circle centered at 1, 3 with any radius. So it's not a certain circle. It's more of like your compass that's still able to move. But as soon as you establish a distance, now you have an actual set circle with a set radius, etc. So that is one standard form. But here's something crazy. I actually want you guys to add this to your notes. Just because it's really helpful for calculus and your honors, so maybe you're going there at some point in time. I want you to write another alternate form of a circle? Another alternate form of a circle? Yes, there's the x minus h squared plus y minus k squared equals r squared. But the alternate form is ultimately y equals the square root of, and this is what happened when we got y by itself to put it into the graphing calculator. So in function form, kind of, y equals square root of r squared minus, how do I want to put this? X minus h squared. Ugh. Got nasty. Lo siento. If you guys notice, I did stop my square root. I showed the end of my square root with a little tail, not because it's proper, just because for me it's easy for you guys to see where it ends. And then plus k. So because of that whole, hey, it could be a square root sort of deal. If you got y by itself, if they gave it to you kind of like in function mode, where they did get y by itself, square root of r squared minus x minus h squared plus k is technically half a circle. Specifically, this would be the top half of the circle. Why is it only half a circle? What would you need to have the whole thing? Oh, you have an x. How do you get a whole circle? Plus or minus. Yeah, plus or minus. Now, ultimately, this is a weird form because in that one, I put the k first. It was k plus, k minus. This one, I'm putting the k at the end. So you could do it either way. For our purposes, or for my purposes, I'm being a little selfish because I teach calculus too. I like it in this form better. But plus or minus square root of r squared minus quantity x minus h squared plus k. Would you actually need that in homework? Probably not. They're probably going to be fine with you just leaving it in this form. But if you ever wanted to double check your answer, you would have to get y by itself to plug it in your grapher to check it, unless you were able to do something like Desmos where you could just type it in this, what we would call implicit form as opposed to explicit. Implicit is just kind of all hidden and it's there, but it's kind of hard to see. Explicit, y is by itself, there's that function right there. Anyway, let's get to example number 8. Should be pretty easy, right? Plug in h, plug in k, plug in r, we're done. Then they give us something like this. The point 3,4 lies on a circle whose center is at negative 1, 2, as shown in the picture. Write the standard form of the equation of this circle. Maybe it's not too bad. But we have time. Ready, set. You guys strategize in your groups and get me an answer for it. Go. People in the front, they want to see more than your back. Oh, blue pen. Thanks, Rachel. Plugging in HK should be easy, right guys? Because HK is specifically the center, and they gave us the XY of the center, right? Just making sure our reasoning is okay. Right? So what are you missing? The R. But what is the R? The distance. Good. Did anybody make a right triangle for distance instead of the formula? Just curious. No? Okay. That's all right. 2 to 4 is 2. From negative 1 to 3 is 4. Did you guys get the same thing? Square root of 20 when doing x2 plus x1 over, or squared is y1 squared? Good. Is that the proper form? No. What's the proper form of root 20? Because it's root 4 times root 5, right? And square root of 4 is 2. So then plugging into your standard form. Who was your h? When you plug in a negative 1 with subtraction, what can you do with that subtraction? Minus a negative will be plus. Good. My k is, and my r is 2 root 5. Ugh, but I have to square it? What would be easier to plug in than 2 root 5 if I'm squaring? Yeah, maybe not simplified. Since it's not like my final answer, I'm using it. Rad 20 looks so much easier. You should have been able to do the same thing with 2 rad 5, square the 2, square the rad 5. But you do end up with the final equation of x plus 1 squared equals 20. Why did we not write it in that big old nasty form with the radicals and the plus or minuses and all that jazz? It was easier just to leave it like that. But when might you want to use this form? If it was an even and you couldn't check your answer, but you had a picture of what it should look like, couldn't you plug into this form also, put it in your calculator, and see if it matches up? You could. You could. You don't have to, but you could. Kiddos, with that, what's due tomorrow? Section 1.2, Google Classroom, really quickly. Just making sure it's the beginning of the year. Stuff is kind of weird. I know we already checked yesterday that homework number 1 was okay. In the sense of that wasn't the page that I wanted to actually go to. I apologize. There we go. All 16 of you have turned it in. That's perfect. Remember coming back here to the forms. I think all 16 of you now have turned in the Google form. The form, remember, 2 things had to happen. The first thing was that you hit the submit button at the end of the form itself. And the second thing was to go into Google Classroom and then hit the mark as done. So 2 things were supposed to be done. Now I have all of you guys having had it turned in because no one's still there. So I can go ahead and go give credit to those of you guys that for one reason or another forgot to mark as done. And I did give full credit even if it was turned in late for those, just as we were figuring things out. Same thing with homework number 1, but starting with homework number 2, the deadline is solid if you don't have it in on time. Then I am going to have to take off some points. Sound good? Okay. If any of you guys have some issues with the phone or with the app or with not having a smartphone, etc., just come talk to me. We'll figure things out. However, before you leave for today, I do have your graphing calculator quizzes graded. And so I want to give them back to you. However, there were, not unnecessarily everyone's, but on a lot of yours, there was at least something that you missed, something that kept you from a 20 out of 20 for most of you. There wasn't any bonus, so if you have a 20 out of 20, you didn't miss anything, you're good. You won't have to do corrections. If you ever don't have to do corrections, you're just going to staple, I know it's awkward, a blank correction paper on top of your quiz or your test, because that's telling the TA, hey, I did it, here's my name, I'm turning it in on time, but I didn't have to do any corrections. You just saved yourself time and got a better grade on a quiz or test. Go team. Can I have one person from every group go to the back table and pick up a white sheet for everyone in their group? Those are the correction papers. Meanwhile, when I call out your name, just come on down and grab the quiz. It's easier than me coming to you. Lacey, come on down. Angelique, come on down. Oh, Vicente went into stats. Robert. Wyatt. Jason. Jason Lou. I don't know if we have more than one. Aiden. Austin. Kim. Oh, Aiden. Austin. Yeah, Kim. Kyle. Johan. Sam. Adam. Kathleen. Zoop. Zoop. Tony. Jaden. And Vico. Okay. Some of you guys need to check out the score and consider what went wrong. Maybe it was something little, maybe it was something big. On a few of your papers, if I saw like a whole section that something was off, everyone could have made very different mistakes in your calculator. So as you're doing corrections, I think I told some of you, figure out what went wrong and come show me. If you can figure out what you did, maybe I can give you some partial credit. Maybe I can give you some partial credit. And on this first one, just because a few of you weren't quite as ready as you should have been for one reason or another, we might be able to get just a few points back because it was your first quiz with me. Just because there are a few of you, something went like horribly wrong on your calculator. I don't know what it was. So try to figure out what went wrong. Try to figure out what you did. Come talk to me if it's anything below like a 15 out of 20, and we'll see if we can get you any points back. But for most of you, the test corrections are just going to be normal. I'm just trying to find why wasn't this perfect and how could it have been perfect. That test correction form, you guys peeking at it? There are 1, 2, 3 columns? 4 columns. Okay, there are 4 columns. The leftmost column, the very first column you see, says missed concept, right? That's supposed to be a word or two about what went wrong. For instance, if you missed something on number 1, you could say zeros. If you missed something on number 2, you could say intersections. Okay? The second column is just what's the problem number itself. I missed points on number 4. I missed points on 4A or 4B or 4C or number 2. The third column, pause, is what you were supposed to do right. Now this is in your calculator, so maybe using some buttons and showing me actually what you should have done. And number 4 is like a sentence or so about, oh, I figured out what I did wrong, or my rounding was off, I thought this, I did that. It's just supposed to be a sentence or two explaining it. Sound good? Okay, it's a homework assignment. It's going to be due the corrections probably on Monday, but I'll write that on the board tomorrow so that you guys know. All right, I'll see you later.